Dear students, let's see this question which is given in advance 2015. So in this question is saying that in the following circuit the current through the resistor R is equal to 2 ohm is I ampere. That means in this circuit the current through the resistor R is equal to 2 is I ampere. That means in this current is given as I ampere. And he is asking that the value of I is. What he is asking? He is asking the value of I is. Again I am saying this question is easy to solve. So first we will try to understand. We will try to understand here 1 ohm resistance is given and here is 2 ohm, 8 ohm. Here it is given as 2 ohm, 4, 10, 6, 12, 4. Here 6.5 volt and it is 2 ohm. So now, first we have to find out the effective resistance here. We have to find out the effective resistance. We have to make the circuit simple. After that, we can able to find out easily. For that, what we have to do is we have to break down. We have to break all the resistors. How to break all the resistors means. So from here itself, I will explain. So try to understand. When we see this diagram, in this, I can clearly understand that, see this point, for example, I will write here this point A and point B. So in between the 2 points, and this side if you are observing clearly, is P, is Q, is R and is S and is galvanometer resistance. That means here we can apply or we can check whether we can apply Wheatstone bridge or not. Generally, whenever the 5 resistances are there, out of 5, 4 should be like P, Q and R and S, and the another one should be the bridge between the two. So next we have to check whether the bridge is balanced or not. If bridge is balanced or not, if you will see here, P by Q is nothing but 1 by 2. And here R by S is 2 by 4, 2 by 4 can be written as 1 by 2. Which means P by Q is equal to R by S. When P by Q is equal to R by S, then there will be no flow of current through the galvanometer resistance. No flow of current through here. So in this junction, there is no current, which means simply we can remove this resistance. I hope you understood, right? Again I am explaining. We have to check P by Q is equal to R by S. When P by Q is equal to R by S, no current through this resistor, so I can remove this one. So just I am removing. Clear? When I am removing, just try to understand this resistance and this one. These two are in series. In series, this is 2 and this is 1. So in series it will be 3. So in between these two, the effective resistance is 3. So again I am modifying. Effective resistance is 3. Clear? Now, in between these two are connected in series. So the effective resistance between these two is, this is 4 and this is 2. So 4 plus 2 is 6. So I will write this is 6. I will remove this one. I will write 6 series. 6 1. And when we observe these two are from this point A and B, these two are connected in parallel. These two are connected in parallel. So we know the parallel formula. 1 by R is equal to 1 by R1 plus 1 by R2. So generally if you will solve 1 by R, I will write 6 plus 3 by 18. So 1 by R can be written as 9 by 18, which can be written as 1 by 2. So R is equal to 2 ohms. R is equal to 2 ohms. These two are connected in parallel. If you calculate the effective resistance between the two is how much it is? 2 ohm. So again I will remove this one. I will write only the 2 ohms. 2 ohms. Clear? I modified in between A and B. Now again if you are observing here, see this one. Again point, now I am considering point A and point B here. point A, point B. Here, if you are observing this one again, it seems to be Wheatstone bridge. It seems to be Wheatstone bridge. How it is? P by Q and R by S and galvanometer. P, Q, R, S and galvanometer resistance. Again, I will check whether P by Q is equal to R by S or not. So P by Q means 2 by 6. Here I will erase. See here, P by Q means 2 by 6, which is equal to 1 by 3. R by S, which is nothing but 4 by 12. 4 by 12 is equal to 1 by 3. Again we know P by Q is equal to R by S, which means there is no flow of current through 10 ohm resistance. There is no flow of current through 10 ohm resistance. Then I am removing this 10 ohm resistance. If I am removing this 10 ohm resistance, you can clearly understand that this 2 ohm and 4 ohm are in series, 6 ohm and 12 ohm are in series. So now 2 plus 4, 6. So I will write the effective resistance is 6 ohm. 6 ohm here in between, here it will be 6 ohm. And in between these two are connected in series. So it is 12, 6. 12 plus 6, it is 18. 18. Here it will be 18. Now, this 18 ohm and 6 ohm are connected in parallel. So we will apply the parallel formula. See, 1 by R is equal to 1 by R1 plus 1 by R2. So we will write 1 by R can be written as 6 plus 18 by 18 into 6. 18 into 6. So 1 by R is equal to 18 into 6 by 6 plus 18 means 24. 24. You can calculate, you will get the answer. Just try to find. We will get R is equal to 9 by 2. R is equal to 9 by 2. Then the effective resistance between the two is how much it is? 9 by 2. So again I am removing this one. I am removing and here it will be 9 by 2. Now if you see, it is a small circuit having two resistors and one potential, and here current is given as I. We have to find out the value of I. So here we can write I is equal to, again we will find the effective resistance between the two. Is 9 by 2, this one is 2. So here we will write, you will write here in between the two, total resistance I will write, R total can be written as, R total can be written as 2 plus 9 by 2. R total can be written as 4 plus 9 by 2. 13 by 2 R total. And here V is given as V is equal to 6.5 volt. And I have to calculate current here. So I is equal to V by R. V by R means 6.5 volt by R is 13. 13 by 2 I will write here 6.5 into 2 by 13. So here 13 by 13 which is equal to 1. So I is equal to 1 ampere. I is equal to 1 ampere. So here how much current has to flow? Here I is equal to 1 ampere. 1 ampere. Clear? Again, by small formulas like resistors in series, resistors in parallel, we can able to find out the value of I in the given circuit. I hope you understood. Thank you.